Did you know that graph neural networks, or GNNs, have been rapidly gaining traction and are now being used in everything from social networks to drug discovery? That's right. The growth and impact of GNNs in AI applications is nothing short of astonishing. So, what exactly are graph neural networks? Well, GNNs are a powerful tool designed to process graph-structured data. They've become super relevant in various fields because they can capture complex relationships and interactions that traditional methods just can't. Whether it's analyzing social connections or understanding molecular structures, GNNs are changing the game. Now, let's talk about the problem we faced before GNNs came along. Traditional neural networks are great, but they struggle when it comes to handling relational data. Think about it, they treat data as individual points rather than interconnected entities. This limitation makes it difficult to extract meaningful insights from data that is inherently relational, like social networks or biological data. So, there was a clear need for a new approach that could leverage the power of relationships between data points, enter graph neural networks. So how do GNNs actually work? Let's break it down. At their core, GNNs operate on graphs, which are made up of nodes and edges. Nodes represent entities, while edges represent the relationships or connections between them. The magic happens through a process called message passing. During this process, nodes exchange information with their neighbors to update their own representations. It's like gossiping. For example, if you think of a social network, each person is a node, and their friendships are the edges. If one person shares a piece of information, it can spread through their connections, allowing everyone to stay updated. This ability to propagate information through the graph allows GNNs to learn meaningful patterns and make accurate predictions based on the underlying structure of the data. Now, let's highlight a groundbreaking application of GNNs. One of the most exciting areas is drug discovery. Researchers are using GNNs to predict how different molecules will interact with each other. By modeling molecules as graphs, where atoms are nodes and bonds are edges, GNNs can analyze complex relationships and identify potential drug candidates much faster than traditional methods. This could revolutionize the pharmaceutical industry, making drug development more efficient and effective. It's a perfect example of how GNNs can transform a field and spark innovation.